Welcome! In today's video, we'll explore a fundamental concept in data structures and algorithms, reversing a string. This is a classic problem that's often asked in coding interviews and serves as a great way to understand basic string manipulation. We'll not only go through the steps to reverse a string, but also analyze the solution to give you a deeper understanding of how it works. Let's start with a problem statement. Imagine you have the string "Hello World." Our task is to reverse this string so that it reads "Doro Ollie." At first glance, this might seem straightforward, but we'll take it step by step to ensure we understand the logic behind it. To reverse a string using a loop, here's the plan. 1. Initialize 2 pointers. We'll start by setting up 2 pointers, one at the beginning of the string, left, and one at the end, right. 2. Swap characters. Next, we'll swap the characters at these 2 pointers. For example, swap the first character with the last character, the second with the second last, and so on. 3. Move pointers. After swapping, we'll move the left pointer 1 step to the right and the right pointer 1 step to the left. 4. Repeat until middle. We continue this process until the left pointer is no longer less than the right pointer. At this point, all characters have been swapped and the string is reversed. Let's translate this plan into code. We'll use Python for our example, but the logic is similar in other languages.
Python.
Def reverse_string s. Hashtag convert the string to a list to allow modification. S equals lists. Left, right equals 0, lens 1. While left, right. Hashtag swap characters at left and right pointers. S left, S right equals S right, S left. Hashtag move the pointers towards each other. Left plus equals 1. Right dash equals 1. Hashtag join the list back into a string. Return. Join S. Hashtag test the function with a sample string. Print reverse_string hello world. Hashtag output. Doro Ollie. This function takes in a string, converts it to a list, and then swaps characters from the outside in. Once all the characters are swapped, it joins the list back into a string and returns it. The test example shows it successfully reverses hello world into Doro Ollie. Now, let's talk about the efficiency of this solution. The time complexity is O, and because we traverse half of the string, where n is the length of the string. The space complexity is O1 because we're performing the swaps in place without needing extra space proportional to the input size. Understanding this is crucial because in coding interviews and real-world applications, efficient solutions are often favored. Reversing a string is a great example of how we can achieve efficiency with a simple yet effective approach. Before we wrap up, here are a few tips. Try implementing this in other languages like Java or C++ to get comfortable with different syntax. Experiment with different input cases, such as an empty string or a string with special characters, to see how the function handles them. Practicing variations will not only solidify your understanding, but also prepare you for any twists you might face in an interview setting. Thanks for watching. We've covered a lot today, from understanding the concept of reversing a string to implementing it in code and analyzing its complexity. I hope this gives you a strong foundation to tackle similar problems. If you enjoyed this video, don't forget to like and subscribe for more coding tutorials.
See you next time.